Okay, in last class, we have seen about different ways of taking backup, that is full backup, and then cumulative backup and incremental backup. And we have also seen how to restore from cumulative backup as well as incremental backup. Now, today we are going to discuss about the different backup methods which can be used to take a backup. Now, these are the different methods which can be used to take a backup, that is cold or offline backup, hot or online backup, then open file backup, point in time replica backup, backup file metadata for consistency, and bare metal recovery. These are the different methods for taking a backup. Now we are going to discuss these methods one by one. Now the first method is cold or offline backup. Now in this type of backup, the system is not going to be running. Means while taking a backup, the system is shut down. Means to take a backup of a system, the system has to be turned off or shut down. This type of backup is called as cold backup, and the system is turned on means it is offline, hence it is also called as offline backup. In this type of backup, the system has to be turned off to take a backup. This is the first way of taking a backup. Then the second way is called as hot or online backup. Now in this method of backup, the system is up and running with the user accessing their data during the backup process. Means during backup process also the system is running. While the system is running, at at background you are going to take a backup. The system is performing its task, but you are taking the backup of system's data. This type of backup is called as hot backup, and while taking a backup, the system is up and running, means it is online, hence it is also called as online backup. These are the two methods, cold backup and hot backup. The cold backup is also called as offline backup because the system is offline during this backup process, and hot backup is also called as online because while the system is online, you are taking the backup of the system. Okay, then the third type of method. These two are the methods which are used for taking a backup of online files, open open files. In some cases, consider the hot backup. The system is running and you want to take a backup. In that case, if the system is running, the system is going to open some file, and if the files are open and if you are taking the backups, the files which are opened may not be backed up because the operating system is going to have some locks for the open system so that the others cannot access those files. In such cases, you can't take the backup of open files. Okay, now how to handle this type of situation? Now for this type of situations, there are two ways. The first way is to retry operation. Means you are going to perform a backup process, but for the open files, you are going to retry to take a backup of open files after some time, because after some time those files may be closed and you can take a backup. This is the first way of taking a backup of open file. But in some cases, in some systems, there are some files which cannot be closed at the entire life of your system. Means whenever the system is running, those files are going to be open. Means those files are not going to be closed until the system is shut turned off. In such case, the retry operation may not work because the retry operation is going to take a backup whenever that file is closed. But there are some operating system files which are not going to be closed until you shut down your system. So for such cases, we are going to use a term called open file agents. Open file agents. Now, what these agents are going to do? These are going to these are going to communicate with the operating system, and they are going to take a replica copy, that is the same copy of the open files for the backup operations. Means whatever the changes you are making in the open files, the same with the same changes, that files backup is going to be taken. This is how the open file agents method work. Then the next method is called as point in time replica, that is PIT. Now this PIT copy method is deployed in the environment in which the impact of the downtime from cold backup is more. Means you can't keep your system down for longer time. In such case, the point in time replica backup is going to be used. Now, what is this point in time replica? It is going to it is going to be the PIT copy. It is going to create a PIT copy which is created from the production data, and it is used at the source for the backup. Means just you are going to generate a PIT copy and you are going to use this PIT copy as a source for your backup, and this is going to reduce the impact of downtime on your system. Means the system is going to be down only for few seconds. Hence, after taking this PIT copy, in background you can take a backup of that particular system with the help of this point in time replica. This is how this point in time replica works. The next method is backup file metadata for consistency and bare metal recovery. Now these two methods are used in a disaster recovery environment. Bare metal recovery refers to a backup in which all the metadata, the system information, and application configurations are appropriately backed up for a full system recovery. Now, this type of backup is going to take, we are going to take this type of backup whenever there is a system disaster. Means your system is corrupted. In that case, you need to take a backup of all metadata, system information, and application configuration, and this is called as bare metal recovery. It is in short you can call it as BMR. Okay, these all are the different backup methods which are used for taking the backup. Then the next concept is backup architecture. Now, how the backup architecture is going to work. The backup architecture is illustrated in this figure, where the backup server, you have backup server, and then backup client and storage nodes. Now the backup server manages the backup operations and maintain the backup catalog. Now what this catalog is going to contain? It is going to contain the information about the backup configuration, and it is also going to contain backup metadata. Now the backup configuration is going to contain the information about when to run the backup and which client to data to be backed up, and so on. All this information is present in backup configuration, and backup metadata contains the information about the backup data. It contains the information about the backup data. Then we have backup client. Now this backup client is the task of this backup client is to uh, gather the data that is to be backed up. Means it has to collect the data that is to be backed up and send it to the storage node. Okay, this is the task of your backup client. And we have a storage node which is also called as which is we have a storage node which is used to store the data onto the storage devices. The storage node is also sends tracking information to the backup server. Means after storing the data to the storage devices, it also sends the information to the backup server. Okay, now these are the different components of the backup architecture. Backup client sends backup data to the backup server or the storage node. Then backup server, it is going to manage the backup operations and it is going to maintain the backup catalog. And storage node, it is responsible for writing data to the backup device. Along with writing data to the backup device, it is also going to send the tracking information to the backup server. This is about the backup architecture. Then we have already seen the backup operation, how it works. we are going to start a backups scheduled backup process. Then backup server is going to retrieve the backup related information from backup catalog. Okay, then backup server is going to instruct the storage node to load the backup media in the backup device. Then backup server instructs backup client to send its metadata to the backup server and data to be backed up to the storage node. Then backup client sends data to the storage node. Then the storage node is going to send data to backup device. And finally, the storage node is going to send the media information to backup server. Now this media information is nothing but the tracking information. Then the backup server is going to update the catalog and it is going to record the status for future use. Okay, this is how the backup operation takes place. Now the second is restore. Once you backed up your data, the next operation is restore in case of loss of data. Now when you want to restore, the first step is backup server is going to scan the backup catalog to identify data to be restored and the client that will receive the data. After that, the backup server is going to instruct the storage node to load the backup media in the backup device, and then data is then read and sent to the backup client. Then the storage node is going to send the restore metadata to the backup store server. Then backup server is going to update the catalog. Okay, this is about how the backup process works and the different. This is about backup architecture and backup and restore operations. Now today we are going to discuss about the different topologies which are present for taking a backup. There are three basic backup topologies. One is called as direct attached based backup. Second one is LAN based backup, and the third one is SAN based backup. And the fourth option is mixing of above three topologies, that is mixed backup. Now we'll start with the first one, that is the backup, that is direct attached backup topology. Now in this direct attached backup topology, the storage node is configured on a backup client. The storage node is configured on a backup client and the storage node is directly connected to the server. The storage node is directly connected to the application server. Now here you can see, now this is your application server and it is going to be your backup client is configured on a backup, so and storage node is configured on a backup client, and you can see here backup device is directly connected to the this application server, and you have connected this application server to the backup server through LAN. Means for only for storing the metadata and for accessing the metadata, the application server is going to communicate with this backup server through LAN. But to store the data on the backup device, it is directly connected. Means the LAN is going to be used only for sharing the metadata, not for sharing the backup data. The backup data is going to be directly written to the backup device. This reduces the overhead due to the LAN connectivity. Okay, this but if you want to store the backup device amongst more than one server, that is not possible here because the backup device is directly connected to this application server. If you have one more application server, then the same backup device cannot be used over there. That is the disadvantage of this direct attached backup. Now the second, the data is directly transferred. Only for accessing the metadata, the LAN connection is going to be used. Now the second is second topology which is used for taking backup is LAN based backup. Now in this LAN based backup, the client, the backup server, storage node, and your backup devices all are connected to the LAN. Now all these four components are connected to the LAN, and the data to be backed up is transferred from the backup client to the backup device over the LAN. The data is going to be transferred from the backup client to the backup device through this LAN. Now this is backup client and it is transferring the data through storage node to the backup device. Hence, all the data has to be processed through LAN. And if you have more than one application server which are using the same backup device, it is possible because the backup device as well as the storage node are present in a LAN. And to access the metadata also, it is going to use the same LAN. This type of topology is called as LAN based backup. Now the third way is a SAN based backup, which is also called as LAN free backup, because you are going to free up the LAN here, hence it is called as LAN free backup, SAN based backup. Now in this type of backup topology, the SAN based backup topology, it is the most appropriate solution when a backup device needs to be shared among the number of clients. In this case, the backup device and the clients are attached to the SAN, not to the LAN. The backup device and the clients are going to be attached to the SAN. Here you can see FC SAN. Now the backup device and the application server and the storage node are connected to this FC SAN network, that is fiber channel SAN network. And if a client sends the data to be backed up to the backup device over the SAN. Here you can see the client is going to send the data to the backup device through this FC SAN. Means you are not going to access the LAN to share the to store the backup data onto the backup device. Just to share the metadata information with the backup server, you are using the LAN. And here you can connect, as this storage node and backup devices are not directly connected to the application server. Hence, you can share these devices, storage node and backup devices, with more number of application servers. You can connect that application server with this FC SAN network so that these two can be shared with the more number of application server. This type of topology is called as SAN based backups or LAN free backup. Then this is an mixed backup where you have mixed which type of topologies. This is SAN based topology, and you have also mixed the LAN based topology. Here in this it is LAN based, in this it is SAN based. In both cases the LAN is used for sending the metadata, but in this first case to send the data you are using the FC SAN. In second case you are using LAN for sending the data, also for sending the metadata. Now the next concept is how to take a backup in NAS environment. Okay, now there are 4 different ways in which you can take a backup in NAS environment. Now we are going to discuss those 4 ways one by one. Okay, the first type of backup topology which is used in NAS environment is application server based backup. Application server based backup. Now in this the NAS head is going to retrieve the data from the storage array over the network, and it is going to transfer it to the backup client which is running on the application server. And then the backup client is going to send this data to the storage node, which in turn is going to write the data to the backup device. Now see the NAS. This is how the data is going to be backed up, and it's going to be stored onto the backup device. Now these bubbles, this line bubble is representing backup request. This is data, how the data is flowing, and this is your metadata. Now from where the metadata is accessed? From your NAS head. Just a second. Okay. This is the first approach for taking backup in NAS environment. Now, the second approach is called as serverless backup. Just a second. The second approach is called as serverless approach. Now in this approach, the network share is mounted directly on the storage node. Means there is no network share, it is directly mounted on a storage node. Now this is going to avoid the overloading of the network during the backup process. Now let's see how the backup is going to take. The backup server is going to access the backup request from application server, and then the data is going to be backed up from storage node to the backup device. In this, the application server is not involved in the backup process. It is just used for sharing the metadata and just for sending the backup request. This is the second. Now the third way is taking a backup in NDMP. Okay, the third way of taking a backup in NAS environment is NDMP. NDMP stands for Network Data Management Protocol. Now, in next two approaches, we are going to use this protocol backup for backup of NAS environment. We are going to use NDMP. Now this NDMP is a three-way method where it is going to separate a private backup network, and it is going to establish between all NAS heads and the NAS head connected to the backup device. Now let us see how this works. The backup server connects to the NAS head, sends the backup request to the NAS head, and the data is going to be transferred directly from storage to the NAS head to backup device, and only the metadata is going to be sent to the backup server. Okay, only the metadata is going to be sent to the backup server. This is how the NAS backup can be taken in NAS environment. Okay, then the next and the last point of this chapter is backup technology options. Now, how we can take a backup? What are the technologies you can use to take a backup? Means where you can take the backup. Now there are three different ways, or there are three different options where you can take the backup. Now first option is backup to the tape, that is physical tape library. This is a traditional method of taking backup. And then second way is backup to the disk, and the third way is backup to the virtual tape. Here the first method you are using physical tape, whereas in last method you are using virtual tape. Now, backup to tape is an traditional destination for backup. Means since long time you're using this backup tapes for taking the backup because it is a low cost option. But the here the data is going to be read or accessed in sequential or in linear access. No, there is no random access, and you can have a multiple streaming of data. You can access access the data through multiple streaming, and backup streams from multiple clients to a single backup device is possible. Now here you can see here this color indicates the data from stream 1. This purple color indicates the data from stream 2, and yellow color indicates the data from stream 3. Now this is how the physical tape library look like. These are the some cartridges where you can import export mailboxes are there, linear robotic systems are there, and this can be connected to a storage array. Now what are the limitations of this tape drive? Now the tape drive limit, the first limitation is the reliability. Now the restore performance is very low compared to other options, hence the reliability is very less because you need to mount, you need to load to ready it, you need to rewind and dismount number of times. For all these purpose, the restore performance is very less. And the second disadvantage is it provides only sequential access. If you want to access the data randomly, it cannot provide, and cannot be accessed by multiple hosts simultaneously. Means the multiple hosts can write the data simultaneously, but they cannot access it simultaneously. Controlled environment for tape storage, then wear and tear of the tape may damage your data. Shipping and handling challenges are there, and tape management is also challenging. Okay, these are the limitations of first approach, that is tape backup to tape. Now the second approach for taking the backup is to take a backup onto the hard disk. On your hard disks, you can take a backup, and it is easy to implement. You are having faster access. You can have you have more reliability. You can access the data randomly. You can choose multiple hosts can access the data, and it is going to enhance the overall backup and recovery performance. Now to illustrate this last point, enhancing overall backup and recovery performance, let us take this example, tape versus disk restore compilation. Now, typical scenario is that 800 users, 25 MB of mailbox, and 60 GB of database. Now, if you use a disk, then the backup and restore process takes 24 minutes, only 24 minutes. And for the same application, if you use tape, the backup and restore operation is going to take approximately 108 minutes. Recovery time in minutes means the total time from point of failure to return of service to email users, means the time starting from the failure up to recovery time. All time is calculated here. For disk it is 24 minutes, and for tape it is 108 minutes. Hence, it is going to enhance the overall backup and recovery performance by taking the less amount of time. Then the next is virtual tape library. This is one more options for taking a backup. Now here you can compare all these three options for taking backup: tape, disk, or backup disk, then virtual tape. Now offsite capabilities are present in only in tape, not in disk, but in virtual tape it is also present. Reliability, here tape no inherent protection methods, but in disks you can have a RAID and a spare disk. In virtual tape also you may have a RAID and a spare disk. Performance, it is load times are more and subject to mechanical operations. The disk backup to disk is faster single stream, and virtual tape is also faster and single stream. Use the tape is used only for backup only, and disk can be used for both. You can use the disk for backup also and for storing the production data also. Whereas virtual tape library can only be used for storing the backup data. Okay, this is about the backup and restore operations. Okay, now this completes the second chapter of your third module. Almost it completes your third module. One more chapter is remaining, that is replication of data, remote and local and remote applications.